So I'm going to talk about systems of equations here. And if you know me, a lot of times I write in sentences in math. I always write in sentences. It's good form to write in sentences. This is the one time I will not write in sentences. And the reason for that is that it becomes extremely cluttered. If I was going to do this, I'd use a kind of a different method, but this is how I want you to do it. Okay, so I'm going to talk about a couple of ways to solving these equations here, and I'm going to go over them in this video. It's just an introduction to the concept. Now, in order to figure out what x and y are here, so what you see here are that there are two equations, two equal signs. That means that there are two equations. The number of equations are equal to, so we have two equal signs here, so 2. And then we have the number of variables. Well, we see that x and y are only two variables here. That means we have two variables here. When these match, it means you can figure out what those are numerically. It means you can figure out what x is and what y is numerically. That's the important idea of this. Now, the first way, I'm gonna lead you up to this idea, is that you can actually what is known as add equations together. What I mean by that is that if you have this equation up top, and this one also holds true, you can add them together. So let's add them together. So you have 1y plus 6y is 7y. And then you have 3x plus 9x is 12x. So it's 12x. And then negative 7 plus a negative 15, in other words, minus 7 minus 15 is negative 22. So I can write negative 22 here. So you can actually add equations together. You can do that. I won't use this notation necessarily, but it's a good way to visualize it. You can add these values up. As long as their variables are matching here, and you can add up the numbers along here. You know, you have that 1 there. You can add those together. Now, another important concept to understand is that you can take an equation and multiply it by a number. What I mean by that is that, see this equation up top here? I can take that equation right here, and I can multiply it by any number I want, but I have to be careful. I have to be cautious. Now, what a lot of people get in the habit of doing, and I'm pointing this out because I used to do it, and my math teachers never corrected me. Shame on them, but I'm going to show you what I mean or how I want you to do it. What you see here with this first equation is that I can take this equation and I can multiply it by a number like 6 here. So I'm going 6 times y is 6y, and 6 times 3 is 18, so it's 18x is equal to 6 times negative 7 is a negative 42. I used to write like that, where it's like that. What you want to do for this process, it's a good visualization of the idea, but instead of notating it like that, this doesn't mean anything. You can't multiply a number by an equation. What you want to do is instead you want to multiply the left-hand side by 6 as well as the right-hand side by 6. That's what you're wanting to do. You can multiply both sides of the equation by 6. Again, you have 6y, and then you have plus 18x equals negative 42. It's the same process. That's the notation you want to use for this stuff. So what you see here is that I can scale essentially the entire equation by a number. So I can go and multiply it through by the value 6. And we can also add equations together. But this leads me to a very important idea, is that you can add equations together and get a term, like a y term or an x term, to cancel out, to be gone. You can get that term to be 0. So what I mean by that, so I have this equation here and I have this equation here. Now let's get into the actual solving part of it. I'm just going to make that y. Okay. So what I'm going to do here is I'm going to take the top equation and I'm going to multiply it by a number. That number, I'm going to multiply it by a -6. I'm going to show you why I'm multiplying it by a -6 here. When I multiply the top equation by a -6 here, what you see is that you're going -6 times y. So you're going -6y. So right here I have a -6y. Then you're going -6 times 3x, so that's -18x. And you know that's going to be equal to -7 times the -6 is 42, so you're going to have this equation right here. Now, you see here where I have these two equations, if I add them together now, so if I look at this equation right here, ignore this one up top. If I look at this equation here and this equation here, if I add them together, I'm going -6y plus 6y. In other words, that's just 0y. So if I add them together, I get 0y here. I go -18x plus 9x is a -9x is equal to, and then 42 minus 15, if in case you forgot how to do subtraction, 27. So you get 0y minus 9x equals 27. Well, that's cool, so I can figure out what x is here. Because 0 times y is just 0, so we can ignore that. So we have -9x is equal to 27. From this point, we just divide both sides by -9. So therefore, that's the symbol for therefore. Therefore, x is equal to -3. Now at this point, we have to figure out what y is. Now, it doesn't matter which equation we want to put it into. We can just put it into either equation, but we know that 6y plus 9x is equal to -15. From right here, we know that equation works. It doesn't matter what equation I'm throwing it into, but I'm just going to put it into here. So if I put in -3 for x here, what I do is I get 6y. 9 times a -3 is -27 is equal to a -15. So I'm going to substitute what x is numerically into one of my equations. What that allows me to do is it allows me to figure out what y is. So I have 6y right here, and then you're going 27. I'm adding 27 on both sides. So 27 minus 15 is 12. So y, therefore, must be equal to 2. So if we're going to represent this as like a point of intersection, well, what we do is we see we have two of our variables. So we know our intersection of these two linear functions would be -3, 2. That would be known as the point of intersection here. But we just don't figure out what our x and y variables are equal to here. All right, so we can do it like that. The other way to do it, and what I consider is probably the easier way, at least with equations where you have two equations, two unknowns, is to do it this way. That was way one. Way two is this way. I encourage you to take notes and do both ways though and feel comfortable with them. Way two is to figure out, well, and it's to me more of a logical way of doing it, is to say, well, what does y equal here numerically? That's not an equal sign, by the way. That's the symbol for implies. Implies symbol. It means that if this holds true, then this holds true. That's a symbol for implies. Very important that you understand those symbols are different here. So I have y plus 3x is equal to -7. In other words, I can get y by itself. I can get it in terms of x. So I get y equals -3x minus 7. I'm moving the 3x over to the other side, so I get a negative. And there's my -7, so I get this equation over here. Now the reason I have y here, and it's in terms of x, so you have an equal sign, it's all in terms of x, is for this reason right here. What I'm going to do is I'm going to take what y is, and I'm going to substitute it into this equation over here. So I'm going to substitute it. What that allows me to do is get this equation here all in terms of x. So I see no more y variables. It allows me to figure out what x is numerically. So if I get y by itself in terms of x, I take it and I substitute it into that other equation. So I get 6. When you substitute here, remember every time you substitute, they have to have parentheses. So include those parentheses. We know y is minus 3x minus 7, so I'm going to write minus 3x minus 7 here, plus, because that's what y is, plus 9x is equal to -15. Now we use the distributive property here, so you're going 6 times a -3x is -18x. 6 times a -7 is 42. Oh, -42, my bad. So 6 times a -7 is -42. And then you have plus 9x equal to -15. So we're here. At this point, we add 42 on both sides. So you're going 42 minus 15. Let's just write it over here. 42 minus 15. And then you're going minus 18x plus 9x. Well, that's just -9x. So I'm going to write -9x over here. 42 minus 15, you use a calculator or you do subtraction. That value is 27 here. So who cares about that number? That number's 27. So what we see is x equals -3. But we're not done yet. We need to figure out what y is equal to. Now, at this point, I ask myself, what's the easiest equation I can take what x is to plug it back into, and substitute to figure out what y is. So I have a couple options here. I could plug it here and figure out what y is. That's going to be kind of ugly. I'm going to have to get it on the other side, so I don't want to plug it into there. There, I could plug it into. That's my best bet right there, because if I could figure out, well, y is just like that, because I'm just going to plug in that number right there. And so I'm going to use that one. I could also plug it into there, but then I'd have to subtract 3x on both sides, and that's just another unnecessary step. So that right there. So I'm going to use this one. That's the easiest way. We go for the easiest way here to avoid algebraic errors in our work. So we're going to go here. So that means that y is equal to -3. X is equal to -3 here. So I'm going to substitute -3 in for x. -7. Because I'm just plugging in. X is -3 here. So I get y equals -3 times -3 minus 7 right here. In other words, that means y is equal to -3 times a -3 is 9. Minus 7, which is equal to 2. So therefore, we see that x is equal to -3 and y is equal to 2. We can rewrite this as a point of intersection as well, that it would be written like this. So it would be -3 and 2. So that's how we can figure out what x and y are from two equations with two unknowns. All right.